Hi, welcome to the video for mixtures, chapter 2, section 2. All right, so what's a mixture? Mixture is a physical blend, not chemical, physical blend of two or more substances, right? And the composition of a mixture can vary if you add a little more of one substance or a little more of another. Air is a mixture, right? You would hopefully remember from earth science that air is a mixture of things like nitrogen, oxygen, a little bit of CO2, a bunch of other stuff in real trace amounts. But that can change, right? You probably heard in the news or different science classes talking about, decreasing your carbon footprint because there's too much CO2 in the atmosphere, which is leading to higher and higher temperatures. There's two basic kinds of mixtures. There's homogeneous and heterogeneous. Homogeneous, we're going to do a little more etymology here, is from the Greek word homo, which means the same, and genos. Genos is race or kind. So homogeneous means same kind. Everything in it is the same. Heterogeneous is from the Greek word heteros, other, and genus, kind. So heterogeneous would be other kind, or more than one kind of thing in your mixture. Right? These are very important terms you're going to have to memorize. But we're going to talk about some examples that will hopefully help them stick. Okay, so something is homogeneous. It has a completely uniform composition throughout itself. What does uniform mean? Well, it's going to mean the same, right? Everybody on the same team wears a uniform to show that they're on the same team. So the composition is the same throughout itself. And the components are evenly distributed. So when you have a glass of water, it's homogeneous. It's all water. Let's say it was a glass of salt water. Now, unless you put on so much salt that there was some salt just kind of sitting here all the way at the bottom, okay, this would be homogeneous. The salt is all going to be separated or evenly distributed through the entire glass. Heterogeneous, on the other hand, is not uniform in composition. This picture of a salad here is a really good example of something that's heterogeneous. So I take one bite, I might get a little piece of this looks like spinach. Another bite, I might get some of this onion. Another bite, if I'm lucky, maybe a little chicken. So there's going to be, if you sample one portion of this mixture, it will be different from that of another portion. This bite over here is going to be different than this bite. That makes it a heterogeneous mixture. All right, so I'd like you to try to answer some of these in your notebook. You're going to try to write down, is it homogeneous or heterogeneous? We're going to go over these in class. I'm not going to give you the answers now in the video. But air, homogeneous or heterogeneous? What about salt water? Tea? Brass, that one you might have to look up. Vinegar. Hydrogen peroxide. Steel. Salad dressing. An apple. Sand. Paint. Granite. Laundry detergent. And finally, cereal. So try to not guess, but figure out if these are homogeneous or heterogeneous. Now, so the next word we're going to talk about is what's called a solution. Now, a solution is a name to special kinds of homogeneous mixtures. And we usually think of a solution as something dissolved in a liquid or two liquids dissolved together. But it's possible for solutions to be gases or solids. Okay? But a common example of a solution that's a liquid is sugar dissolved in water. Okay? Pictured down here are two solid solutions, and they're usually referred to as alloys. So brass is a solid solution where it's copper and zinc all dissolved together to make this alloy. Carbon steel, probably the best kind of knife you can get for in your kitchen is going to be carbon steel. It's going to be much sharper than a stainless steel knife. I really like using carbon steel knives in the kitchen, and that's another type of alloy or a solid solution. Right. So here's some examples of the different kinds. Right. So you're common, right? You have your liquid solutions. Here's acetic acid in water, and that's vinegar. You can have gas in a liquid, which is soda water, where you dissolve carbon dioxide in water. Okay. But there's some others. Gas in a gas, so we have mostly nitrogen in the air. That should be an N2. Let's fix that. And that should be an O2. Let's fix that. And so you have a gas is dissolved in another gas. That's a solution. Water vapor, a liquid dissolved in a gas. The water vapor becomes a gas, then dissolves in the air. That's another kind of solution. You can dissolve a solid in a liquid. That's another very common one, right? NaCl is table salt, and H2O, water, to make a brine, or more commonly known as salt water. Okay. Finally, like we talked about, you can have a solid dissolved in a solid. Another example is a little bit of copper dissolved in silver, and that gives you sterling silver. Skip. All right, think a little bit about separating mixtures. And even though you might not have thought about it scientifically, chances are you've done it at least once in your past, even at home. But let's say you had a mixture of iron nails, salt, and water. How do you think you would separate this completely? Write down what you think it might possibly be, and that's another thing that we're going to discuss with our groups and as a whole in class. But something you've probably done a whole lot of times is separate the pasta from the boiling water. You're separating a mixture. There's the pasta floating around in the pot of boiling water. When you pour it through here, the water comes out and the pasta stays behind. So you can even think of this, right, where basically the colander, the strainer, is a big filter. Right? Maybe that'll help you with how you're going to separate these. Let's say you have liquids, though, and you want to separate two liquids. Okay? So let's say, for example, tap water. You want to separate the components. Okay? To do that, you have to go through the process of something called distillation. Boy, I'm really bad at underlining these, aren't I? You're going to go through distillation. Okay? So here what happens is we take this whole liquid and we're boiling it. Okay? And when we're heating it up, and then part of it starts to boil, and it's going to form a vapor, and the vapor is going to go through this little tube, and here there's a condenser that's going to make it go from a gas back to a liquid. So distillation, we're separating these liquids based on their boiling point. And it can be really cool if you have two liquids mixed together and there's no way to separate them, but their boiling points are different. You can separate them via distillation. All right, so let's think about a couple of things. What physical properties could be used to separate iron filings from salt? All right, think about that, write it down. And then also think about the following here. Which ones are homogeneous? Which ones are heterogeneous? Now remember, heterogeneous is different kinds. So if one piece of something is different than another piece of something, it's heterogeneous. If one piece of something is the same as every other part of it, it's going to be homogeneous. So try to answer each one of these in your notebook as well, and we're going to talk about all these in class. All right, that was Chapter 2, Part 2, Mixtures. Hope you learned a lot. Hope it wasn't so bad listening to me for so long, and I'll see you guys soon.